guys come in. I think we'll probably get started. Looks like we got about 14 people on the call. I just wanted to say good evening, everyone. Thank you for taking the time to join us tonight for the Randall Road at Big Timber Road virtual public information meeting hosted by the King County Division of Transportation. My name is Candy Thomas, and I'm the King County Project Manager for this intersection improvement. This virtual public information meeting is being held in place of an actual in-person public information meeting due to the ongoing coronavirus pandemic. Our project team will present all of the information which would have been presented at an in-person meeting, and you will have the opportunity to ask questions regarding the project and the proposed improvements. Now, I would like to introduce the consultant team project manager, Amy McSwain from Hampton, Lenzini and Renwick, as she will walk us through the project.
Thank you, Candy. And thank you again, everyone, for taking the time to join us this evening to learn more about this project. As Candy said, my name is Amy McSwain, and I'm the project manager for Hampton, Lenzini and Renwick. Chris Olcott, our drainage engineer, will be joining me for the drainage portion of this presentation. Tonight's presentation will be broken up into sections, followed by a short time for questions after each section. First, we'll go through the project introduction, which includes the project limits, the purpose and need, what was analyzed to determine the necessary improvements, and the crash data. We will follow that with a question and answer session. And then once all the questions have been answered, then we'll discuss the proposed improvements. This will include the lane geometry or lane configuration and what the intersection will look like after the project is complete. Some of the key features of the project, and then typical sections, so you get an idea of what it will look like to drive through the project from the driver perspective. We will follow that with another question and answer session, and then the third section will be the project impacts. In this section, we will go through the environmental impacts, including wetlands, trees, and noise, followed by drainage, including roadway runoff and detention requirements, and finish with land acquisition, which is any property that would need to be acquired as part of the project. This section will be followed with another question and answer session. This format will allow us to focus on the individual sections and make sure that everyone's questions are answered. We will wrap up the meeting with the project timeline, where we are now, where we are going next, and when we anticipate this project will be completed. There will be a final question and answer session at the end. When the presentation is over, we will stay active until 7:30 for anyone who joins late or has further questions. Before we begin, there are some housekeeping items to review. There are two ways that questions can be asked during this meeting. The first is to type them in the chat box. You can find the chat box icon at the bottom of your screen. This is the icon that says chat and has a little speaking bubble above it. Clicking on this icon will open a box on the right side of the screen where you can type your questions at any time during the presentation. Questions that are entered into the chat box will be answered during the question and answer session that follows that portion of the presentation. The second way to ask questions is verbally by raising your hand. The raise your hand feature is also found at the bottom of the screen in the taskbar. There is an icon called reactions. By clicking on this icon, it will bring up a secondary menu that will give you the option to raise your hand. Clicking on the raise hand command will notify the host of the meeting that you have raised your hand, and at the end of that portion of the presentation, you'll be called on to ask your question verbally. The web version of Zoom does not have the raise hand function, so you can either download the Zoom app or use the hand clap action to notify the host that you have a question. Those that are calling into this meeting via the phone can dial *9 to raise your hand to ask questions. All questions, both text and verbal, will be recorded and included in the meeting's documentation. During the meeting, we ask that you keep your computer or tablet muted unless you've been called on to ask a question. Phone attendees can mute and unmute by dialing *6. Attendance will be taken from the attendees present on the Zoom call, though you may also use the chat box to sign in with your name and who you're representing, so that you can also be included in the meeting documentation. This meeting will be recorded and available on the project website following the end of this meeting. So the first segment of the presentation this evening will be the project introduction. We will go over basic information about the project, our project limits, the purpose and need of the project, what we've analyzed, and the crash analysis findings. The intersection of Randall Road and Big Timber Road is a signalized intersection located in Elgin, Illinois. It is also partly in unincorporated Kane County. The project limits along Randall Road are the Claude Hansen Bridge at the south end and Capitol Street or Holmes Road at the north end. Capitol Street and Holmes Road is the intersection with the entrance to Advocate Sherman Hospital. The Big Timber Road project limits are Gateway Drive at the west and Jansen Farm Drive on the east. There are 4 parts to the purpose and need for this project. We will walk through each of them individually on the next slides. The first part of the purpose and need is intersection capacity. Most people who drive in this area experience firsthand the length of time it can take to get through this intersection, especially during rush hour. Often, it takes more than one green light, sometimes multiple lights if an ambulance needs to get to the hospital. This tells us that the existing intersection is over capacity, with long lines of vehicles and delays. Adding additional through lanes are needed to accommodate the existing and future traffic growth along Randall Road. The turn lanes are also not long enough for the existing or future traffic and will need to be made longer. The second part of the purpose for this project is the intersection geometry. The existing intersection is not at a 90-degree angle or a right angle. It's at a 61-degree skew. This means the drivers sometimes have a difficult time seeing traffic coming from opposing directions, especially turning right from Big Timber Road to Randall Road. To watch for a chance to turn right, drivers need to look over their shoulder rather than directly to the left. In addition, trucks turning from Big Timber to Randall Road have to move more slowly and make wider turns to navigate the intersection. Making this slow movement further limits the number of vehicles that can make those turns during each green light. The third part is pedestrian accommodations. There currently are sidewalks along the east side of Randall Road near Holmes Road and also along the north side of Big Timber Road east of White Oak Lane, but nothing at the intersection. There are also PACE bus stops on the northeast and southeast corners. This project will provide the connection between the existing sidewalks, as shown with a yellow line on this image. The final part of the purpose and need stem from the intersection capacity need. Because it can take so long to get through the intersection, motorists are finding other routes to bypass or go around the intersection. A route commonly used includes Elf Lane and Madeline Lane to avoid the Big Timber intersection. These routes are not designed for nor intended to be used as a main thoroughfare, so part of the purpose of this project is to reduce delays so drivers don't want to find alternative routes. Another function of the intersection affected by the capacity is emergency vehicle access to and from Advocate Sherman Hospital. While emergency vehicles disrupt the movement of vehicles through the intersection, the capacity bottlenecks also make it difficult for these vehicles to get to the hospital quickly. Increasing capacity will allow emergency vehicles to navigate the intersection with less interruption to drivers. Now we understand why the intersection needs improvements. So what goes into determining the best solution? As part of our evaluation, we look at the current traffic patterns and volumes. This included counting traffic at the intersection and then studying the traffic patterns to analyze whether or not vehicles were using alternative routes to avoid the intersection. Roadway projects look for improvements that will function well for many years, not just today. Because of this philosophy, the design has been based on future traffic projections for the year 2050, rather than the current volumes. We also analyzed crash data from the last 5 years, which we'll talk about more in detail shortly. We looked at environmental impacts. What is in the surrounding area? Are there wetlands? Are there threatened or endangered species? Are there any special waste considerations? We will also take into account community impacts. What are the surrounding land uses? Are there any sensitive properties that could be impacted? And then we obtain stakeholder and property owner input. We meet with surrounding landowners and discuss the project's needs and their concerns. We also coordinate with the utilities adjacent to the project. There are overhead power lines, as well as other underground utilities that need to be considered in the design. We've also coordinated with the City of Elgin to incorporate any of their utilities in the area. Then we looked at the existing pedestrian and bicycle accommodations in the area and what the future needs are of the region. And then finally, we also looked at the existing drainage patterns to determine where water is going and how it is flowing around the intersection. We want to make sure that we maintain existing drainage patterns and that we're not going to be increasing flows to the surrounding properties. Our crash analysis looked at the crashes at the intersection for the years 2014 to 2018. We summarized the types of crashes that are found, the types of injuries that occur, and then look for patterns in the data. In our study period, there were a total of 336 crashes, with 89 injury crashes, including one fatality. The largest percentage of crashes were rear ends, followed by turning movement. These two crash types account for 75% of the total crashes. The crash data reinforces the idea that capacity is an issue at the intersection. Drivers are making unsafe movements in order to get through the intersection more quickly. Maneuvers, like turning when there is a smaller gap in traffic, or not being able to stop because the backup of cars is longer than expected, has led to a larger number of accidents. Adding capacity to the intersection, both through lanes and improvements to the turn lanes, will help decrease both of these types of crashes. This completes our first section of this presentation, and we will open it up for questions about the general basics of the project's purpose and need, and what the data has shown us.
Thanks, Amy. It doesn't look like we have any questions just yet, but we can give it a minute or so. If you do have a question, please use the chat box or the raise hand command so that we can call on you.
Yeah, as Callie said, we'll give it about a minute, and if no one has any questions, I'll just move on. Okay, we'll move on. If anyone thinks of any questions, feel free to put them in the chat. So the next section of our presentation is our proposed improvements. Over the next few minutes, we'll go through the intersection as a whole, and then we'll look at each leg in more detail. Looking at Randall Road first, the key features of the proposed improvement include adding an additional third through lane in each direction, both northbound and southbound. An additional northbound left turn lane will be added by restriping the current left turn lane. Today, there is a single left turn lane with a striped outside barrier lane. The striped section will become the second left turn lane. Both the left and right turn lanes will also be lengthened so that the line of vehicles waiting to turn can be contained within the turn lane. The south leg of Randall Road will include a southbound merge lane that will accommodate the proposed eastbound free flow right turn lane. Big Timber Road will be realigned to make it less skewed with Randall Road. The current skew or angle of the intersection, as I said, is 61 degrees. The proposed design improves this skew to 75 degrees. This change will improve sight lines and navigation through the intersection. Converting the current eastbound right turn lane to a free flow movement will decrease the delay for these drivers as they are operating separately from the traffic signal. The second westbound through lane will be extended further west, and the driveway on the northwest corner will be relocated further west of the intersection to improve the safety of vehicles entering and exiting that driveway. These improvements are expected to increase the capacity and improve the safety of this intersection. Sidewalks will be added to the northeast corner to connect the existing sidewalk network in the area. Looking more closely at each leg of the intersection, we will start with the north leg of Randall Road. The project limits on this leg extend to meet the current 3-lane in each direction roadway section, just south of Holmes Road. We will be replacing the curb and gutter, adding sidewalk along the east leg of the intersection. Based on the left and right turning needs in 2050, the right turn lane will be extended 60 feet, while the left turn lanes will be extended over 250 feet. This will provide more storage room within the turn lanes so that the vehicles will no longer line up beyond the turn lanes. On the south leg of Randall Road, the project stops just north of the Claude Hansen Bridge. Like the north leg, an additional through lane will be added in each direction, but will taper back to 2 lanes in each direction at the south end of the project. The curb and gutter will also be replaced on this leg of the intersection. Based on the left and right turning needs in 2050, the right turn lane will be extended 90 feet, while the left turn lanes have been lengthened more than 300 feet. Also added to this leg of the intersection is a southbound merge lane to accommodate the proposed free flow right turn lane coming from eastbound or the west leg of Big Timber Road. This merge lane gives vehicles a place to accelerate before needing to merge with the southbound Randall Road traffic. Moving to Big Timber Road, we'll start with the west leg. Big Timber Road will be realigned so that the angle with Randall Road is not at such a sharp skew. Today, the westbound 2 through lanes taper back to a single lane less than 150 feet west of the intersection. To accommodate the new dual left turn lanes on Randall Road, the 2 westbound through lanes were continued beyond the relocated driveway to allow for an adequate merging distance. The driveway to the office building on the northwest corner will be relocated further west. Moving it out of the left turn lane on Big Timber Road allowed us to provide left and right turn lanes into the property, improving the safety of that intersection. We will be replacing the curb and gutter on this leg of the intersection through the relocated driveway, and then we'll transition to a shoulder section. This leg of the intersection includes a free flow right turn lane. This movement will function independently from the rest of the intersection and will improve the operations of the remaining intersection movements by removing the large number of right turning vehicles from the intersection. The east leg of Big Timber Road will also be realigned with Randall Road, so it is not at such a sharp skew, improving driver sight distance and safety. Curb and gutter will also be replaced on this leg of the intersection. The turn lane storage lengths have been extended 230 feet for the right turn lane and 145 feet for the left turn lane to provide more room for vehicles within the turn lanes. Sidewalk is being provided on the north side of Big Timber Road that continues north along Randall Road and will connect to the existing sidewalk at White Oak Lane. The next 4 slides will give you an idea of what the project will look like from a driver's perspective on each leg of the intersection. The first slide shows how it will look to travel northbound on Randall Road, heading towards Big Timber Road. The upper picture is the existing lane configuration on Randall Road, which includes 2 12-foot lanes in each direction, as well as a right turn lane and a single left turn lane with a striped area between the through lane and the left turn lane. The bottom picture shows the proposed cross section, which now will provide 3 12-foot lanes in each direction, 2 left turn lanes, and a right turn lane. It also shows the southbound merge lane on the left side of the drawing. This slide illustrates traveling southbound on Randall Road towards Big Timber Road. The upper picture again is the existing conditions, what it's like to travel on Randall Road southbound today. There are 2 12-foot lanes in each direction, dual or 2 left turn lanes, and a right turn lane. In the proposed condition, the lower drawing, there will be 3 lanes in each direction, a 12-foot right turn lane, dual left turn lanes, and a sidewalk on the east side of the road, or the left side of this drawing. Now we're looking at Big Timber Road, traveling eastbound towards Randall Road. The upper drawing shows the current roadway cross-section, which includes 2 12-foot through lanes in each direction, a left turn lane, and a right turn lane. The bottom picture is what the road will look like in the proposed condition. There will be 2 travel lanes in each direction, a left turn lane, and a right free flow right turn lane. The roadway has been shifted slightly to the south, which is to the right in this picture, to accommodate for the realignment of Big Timber Road. This final slide shows Big Timber Road traveling westbound towards Randall Road. The upper drawing is the current roadway cross-section showing two 12-foot lanes in each direction, a 12-foot left turn lane, and a 12-foot right turn lane. The bottom picture illustrates the proposed conditions. This shows two 12-foot travel lanes in each direction, a left turn lane, and a right turn lane along with sidewalk on the north side of Big Timber Road. The drawing shows the lanes have been shifted to the north to accommodate for the realignment of Big Timber Road. This concludes this portion of the presentation. We will now open it up for any questions about the proposed improvements at this intersection.
Thanks, Amy. We still don't have any questions just yet, but we can give it a minute or so again. And if no one has any questions, Amy can move on with the presentation.
Well, if we have no questions, I guess we will just continue on. Please, if you do have questions, make sure to just include them in the chat box. The next segment of the presentation is project impacts. In this section, we're going to cover environmental aspects of the project, drainage, and land acquisition. The first environmental impact I'll talk about is wetlands. There were a total of 14 sites investigated during the wetland site visit. 13 of these sites were classified as wetlands with a total area of 7.5 acres of wetlands. Our design team worked to minimize the impacts to these wetlands to the maximum extent possible and ended up with a total of 0.93 acres of permanent wetland impacts. All wetlands impacted will be mitigated through a wetland bank. Trees 3 inches or greater were identified and assessed based on the conditions of the tree. Within the project limits, there were a total of 1,392 trees, with 43 different species identified. Approximately 33 trees will be impacted because of this project. All trees impacted will be replaced on a 1-to-1 basis according to the IDOT tree replacement policy. Detailed landscaping plans will be completed during the next phase of the project, the contract plan preparation. A noise analysis was completed per the IDOT noise policy. Highway noise is dependent on traffic volumes, traffic composition, traffic speeds, and the distance and elevation of a receptor from the roadway. We evaluated 4 receptors on this project, which represented 4 different common noise environments. The common noise environments, which represent a group of similar receptors with similar exposure, included single-family homes, multifamily homes, and hospitals with outdoor spaces within our project limits. As part of this study, the existing noise levels were recorded and then compared to the projected noise levels in the design year if no improvements are made to the roadway, and then also for the proposed improvements. The existing noise levels ranged from 51 decibels at the hospital to 67 decibels on White Oak Lane. The no improvement noise levels varied from 53 decibels at the hospital to 69 on White Oak Lane. And then the proposed improvements varied from 52 decibels at the hospital to 69 at White Oak Lane. The study found that the noise levels in the situation where no improvements have been made will be just as high as in the proposed improvement conditions. 2 receptors are approaching the threshold for abatement, a single-family residence and the townhomes on White Oak Lane. Both locations would need to have a gap in abatement measures, one for the driveway on the single-family residence and for the entrance to White Oak Lane. Noise reduction is not realized when there is a gap in the abatement measure, so the abatement becomes ineffective. Due to this, no noise abatement is proposed on this project. And now we will hand it over to Chris to discuss our drainage.
Thank you, Amy. Good evening. My name is Chris Alcott, and I'm the drainage engineer for this project. There are existing storm sewers at all legs of the intersection, typically wherever there's an existing curb and gutter. So rain falling on the pavement will sheet flow to the curb and gutter where it'll flow until entering an inlet or catch basin, which are connected to the storm sewer pipes. These pipes generally convey stormwater flow southward and discharge into swales or ditches. The flow continues southward and eastward, passing through pipe culverts and ultimately outletting from the project area. Now, a culvert is simply a pipe beneath the roadway, which allows stormwater to flow from one side of the road to the other. There are 3 larger culverts in the project area, a 24-inch culvert along the east leg of Big Timber, a 30-inch culvert along the west leg, and a 36-inch culvert along the south leg of Randall Road. There's also an existing detention basin north of the intersection on the east side of Randall Road. Detention basins temporarily store water to lower the runoff rate. There are also private basins next to Randall Road that were developed for the adjacent properties. This area drains to Tyler Creek. So the runoff from the project area is going to flow southeasterly from the intersection. It flows past Jansen Farm Drive, past the railroad tracks until it meets Tyler Creek. We can go to the next slide, please. The project is designed to be in accordance with the Kane County Stormwater Management Ordinance. The stormwater management system is designed to match existing drainage patterns, improve water quality, and control runoff to protect the areas downstream. While discussing the proposed drainage systems, you will hear or see references to BMPs. A BMP is a best management practice, which is a device or action that will improve water quality in a variety of ways. These can be structural, vegetative, or managerial type practices. Also worth noting, in 2019, the standard that was used to determine rainfall in Illinois changed and is now called Bulletin 75. The result of this change is that designs need to accommodate higher flow rates than before. The improvements at this intersection are designed to manage these higher flows. The proposed roadway improvements will increase the overall impervious area. A stormwater management system is provided to safely convey stormwater from the intersection, reduce the runoff rate, reduce the volume of runoff, and improve water quality. To control the runoff rate, stormwater detention will be provided. This will be in small detention basins, detention in roadside ditches, or detention in oversized storm sewer pipes. All curb and gutter areas will collect stormwater runoff and drain into a storm sewer system. The proposed design aims to utilize the existing storm sewer when possible, mostly on the north leg of Randall Road, or construct new storm sewers when necessary due to size or configuration limitations. Concrete pipe culverts will be provided to replace the existing culverts. The culvert sizes will likely increase. And if we can go to the next slide. So a variety of best management practices, both temporary and permanent, will be used on this project. Many of the temporary BMPs are related to soil erosion and sediment control during actual construction of the intersection. The permanent BMPs include volume controls and water quality improvements. The aim is to capture runoff and keep it on site, slowly allowing it to infiltrate into the soils, evaporate, or be used by plants. This reduces the overall volume of runoff experienced downstream and improves the water quality. So now at this point, Amy will discuss land acquisition, and then we'll have another opportunity for questions.
Thanks, Chris. There are several types of land acquisition that might occur on this project. The first is called a fee simple acquisition, which means that Kane County would acquire the portion of the property in full that they purchase. The original owner no longer has any rights to the land that is bought. This is generally done for roadway widening and drainage improvements. The second is a permanent easement, which means that the county would be able to access the property during construction as well as any time in the future, but ownership of that property is retained by the property owner. This allows the county access to the property for construction and also to maintain any of their facilities that are within that easement. The third type of land acquisition is a temporary easement. In this case, the owner retains ownership of the property, and the county would be allowed to temporarily use that property for a specified term or to complete the construction of the project. These are often used for driveway replacements and roadside grading for ditches. This project includes 1.7 acres of fee simple acquisition and 0.66 acres of permanent easements. There are no proposed temporary easements needed for this project. The land acquisition process starts with determining ownership of the property, preparing a plat of survey and a legal description, preparing an independent appraisal and having a review appraisal completed, and then finally negotiating with the property owner. During the preliminary engineering stage, the plat of survey and legal description can be completed. The remainder of the land acquisition process happens during the plan preparation phase. This concludes this section of the presentation, and we will open it up for questions about the project impacts related to environmental, drainage, and land acquisition.
Thanks, Amy and Chris. I still don't see any questions coming through the chat box or hand raises. We can give this question session a minute or so. Again, if you have any questions, feel free to type them in the chat box or raise your hand and we will call on you.
I will move on. The final segment of this presentation is the project timeline. We are currently in phase 1 engineering, also known as preliminary engineering and environmental studies, and expect to complete this phase of the project in the summer of 2021. The second phase of the project is the contract plan preparation and land acquisition phase. This phase typically takes 18 to 24 months from the end of the preliminary engineering phase. The final phase of the project will be construction. The construction timeframe will be contingent upon plan readiness, land acquisition, and funding availability. Kane County is currently applying for available funding opportunities for the future phases of this project. Construction is tentatively scheduled for January 2025 in the county's multi-year program. This concludes our presentation for this public meeting. There are several ways to provide your comments on the proposed improvements. You can provide comments online at this meeting by either typing your comments in the chat box or raising your hand to ask a question verbally. You can use the Google form using the link that's provided in the chat box or on the project website. You can also visit the project website to download the comment form and mail it to the project manager at Kane County. Or you can email or call the project manager. Candy Thomas's email and address information are found on the right side of this slide. You can also find the project web address on the upper right side of the slide. We request that comments be received by March 19th to be included in the public record. We welcome any comments or questions you may have at this time, and we'll stay on the call until 7:30 for further questions.
Thanks, Amy. It looks like we do have a hand raise. John, if you want to unmute yourself and you can go ahead and ask your question.
Yeah, hi. I had submitted a couple of questions via email. One was about the whether there would be any permanent BMPs put in at the culvert east of White Oak Lane along the Spring Oak subdivision east property line. And then the other was about the, Chris talked about upsizing culverts. And obviously we would wonder if the culvert that is there along our east property line going under Big Timber would be one of the ones that would be upsized.
Chris?
So yeah, the culvert in question, I think that you're saying it's on the east leg of the intersection. Right now it's 24-inch. I would expect that one's probably 30-inch. We'll take a closer look at that one. There's not as much flow to that culvert as there is to the west leg and south leg culverts. But again, I think just probably a combination of, as I mentioned, the increased rainfall values that we're using now are gonna dictate higher flows. And so with that, I would expect to see the culvert size increase. As for permanent BMPs, like for a culvert, for a crossing, the culvert BMPs will likely be just like armoring with riprap to try to just make sure that we aren't eroding around those areas where flows concentrate in the higher velocities. We'll do other BMPs throughout the site to kind of promote like sediment, pull the sediment out of water, water infiltration, those type of BMPs, like, infiltration swales and whatnot is what's being considered.
Would that work likely all be contained in the right of way, or would you need an easement to do the riprap and the culvert replacement?
There, as Amy mentioned, or I think, in the land acquisition, that there is going to be some right of way that's going to be necessary to, increase right of way for the project. And so I expect that it'll be a combination. Some of it can be provided in right of way. There may be easements necessary to provide these in though as well.
Okay, well, the Spring Oaks HOA is basically just concerned about what changes might directly impact the common area and the private properties in Spring Oaks. That's why I'm asking the questions.
Yeah, I think so you're at that's over at the east leg of the the improvements, correct?
Yeah, the very, very east end.
Yeah, there's not, by that point, we're pretty much almost tying back into existing storm sewer. The improvements that we're using a lot of the existing system at that point. Now, I want to say by the time we reach the project limits, it's almost all back to existing. So there will be some new storm sewer that's being proposed to be along the east, but that stops, I would say, I'm sorry, I'm just looking over at my screen at this, a few hundred feet, I'll say, west of the project limits. So by the time we get toward at the project limits, the storm sewer system is going to be mostly the existing.
Okay, well, just to be clear, the existing 24-inch culvert under Big Timber, that's east of White Oak Lane, that will be removed and made a 30-inch, or am I getting the wrong message?
I think I'm not sure if we're talking, there's a culvert that is east of the intersection, west of White Oak Lane.
Oh,
The 24-inch. If there's one east of White Oak Lane, we're probably not touching that.
okay. I didn't think so. I was just trying to.
Yeah, so I think I maybe misunderstood which one you were speaking of. Yeah, there's a culvert. It's a few hundred feet west of the intersection.
Yeah.
That's the one I'm referring to.
Yeah.
East of White Oak Lane, no, we're not doing anything.
Okay. Yeah, the one you're talking about takes the drainage out of the old cornfield that the
Yes.
Hospital owns now.
Yes.
Okay. Thank you.
You're welcome.